Imagine what it was like for your great-grandfather to make his first telephone call. What was it like to suddenly grasp the implications of being able to talk to people who were miles away? How about the first time you saw a job normally done by a horse, done by an electric motor? How unbelievable that must have seemed. The power to do work, delivered by means of an invisible force through copper wires. You probably believe that you will never witness such revolutionary change in your lifetime. And yet, in the next few minutes, you'll be introduced to such a truly revolutionary technology. You are about to glimpse a completely different future, as your grandfather did. What follows is the first videotape demonstration of a series of simple prototype motors that operate using a new system of power generation, a system that offers the world no less than this: a limitless supply of pollution-free energy. This is a working prototype of the Bedini motor generator. This is not just a more efficient electric motor. The Bedini engine you are watching is capturing and making available for work far more energy than the prototype requires to keep itself turning. This available energy is demonstrated by the turning of the shaft at the end of the system of pulleys, and by the intermittent flash of energy into a 120-volt incandescent light bulb. All conventional electric motors known to date consume electricity supplied from an external source in order to turn and furnish useful mechanical power to a shaft. These motors generate heat as a useless byproduct. This heat is evidence of the fact that they are inherently inefficient compared with the Bedini prototype you are watching. The most efficient motors presently available are those that most efficiently overcome the backdrag created by their own internal electromagnetic fields. An inefficient motor might be described as having a coefficient of performance, a COP of 0.45. A modern designer would be thrilled to create a highly efficient motor with a COP of 0.89. But frankly, no one believes it is possible to attain a COP of 1.0. The Bedini engine has attained a COP of 1.0, but in fact it far exceeds 1.0, because as the system operates, it also captures and delivers usable energy.
We're now coming in with something that changes the roots of many of these disciplines, particularly in the electromagnetic field. That's 136 years old. We suddenly are yanking it into the future. We have a technology that we've just cut into, momentarily you might say, just at the beginning, where we can take all the energy we wish from the active vacuum. What this really means is there's nowhere in the entire universe that you go that you can't have all the energy you wish to have. It turns out that it's fairly simple to get the energy out in enormous amounts, anytime, anywhere you wish to. However, the problem is it comes out in a form that's difficult to catch and use. We have to catch it, we have to transform it into a form that's usable to power our motors. But it comes out in an electrical form. It comes out as reactive power that won't move anything, won't do work for us. We have to transform it into real power, which will do work for us.
One characteristic of great inventors is the ability to see for the first time something in a brand new way. Having seen that internal electromagnetic fields can be put to work, inventor John Bedini has developed a number of different prototype designs to demonstrate the new core technology. All the Bedini prototypes adhere to the same basic, simple principles. Some of these prototypes appear elementary in their design. This underscores the fact that the new art demonstrated by the Bedini motor generator is really quite simple and is not the result of some highly complex manufacturing process. Here, Tom Bearden demonstrates a device that uses a tiny amount of current to move air and charge batteries.
We have our primary battery. We are taking a little bit of energy from this battery. It is furnishing a small amount. That actually gets the system set up and begun. We're doing mechanical work with the fan. In this battery, the flash charging, taking energy from the vacuum, is producing more energy deposited in the battery to charge it than we have drawn from this battery. In this particular system, about 8 or 10 times as much, depending on what speed it's working at.
All of the Bedini motor generators share common characteristics. All feature a rotor, or flywheel, fitted with a number of permanent magnets. All feature a timing device and a series of coils. All Bedini engines use a tiny amount of voltage supplied by a battery to power a discrete circuit that at the precise moment reverses the magnetic fields within the engine. This controlled, rapid regating causes a push-pull effect that drives the prototype. A separate set of coils captures the energy from the vacuum as a result of the expanding and collapsing electromagnetic fields caused by the movement of the magnets. The Bedinis are now ready to develop the first generation of full-scale practical prototypes capable of powering a home. In order to exploit this exciting new technology, the Bedinis have registered their new art with the U.S. Patent Office.
A patent was filed on January 13th with the United States Patent and Trademark Office. We are in the process of filing what is called a continuation in part, which means that we're piggybacking on this present application more claims as developer John Bedini improves the art, improves the device, and we will continue to follow that up with more CIPs as the sophistication of the Bedini motor improves and is developed.
The potential of the world is several things. One, of course, is cheap, clean energy that doesn't pollute the biosphere. It doesn't have any unburned hydrocarbons or any nuclear waste or anything like that. So, dramatic impact upon the biosphere and the air we breathe in our cities and everything. The other impact is economic. It means that the energy is ridiculously easy to get and ridiculously cheap. So the implications is, for the first time in history, we have an energy source which doesn't go away. If we go ahead with the technology and learn how to apply it well and catch lots of it, we can power everything we do in our entire civilization, cleanly, cheaply, and economically. John started out as a very remarkable young fellow. I think when he was something like 7 or 8 years old, he started doing electronics, at a very early age anyway. And he got interested in making transistors and things like that, when all of that, transistors were the real rage and everything. And so John would go around Sylmar there and round up on the mountain peaks and all and pick up ore samples of real interesting, all kinds of ore, different kinds of rocks, they would say, nice rocks. And he would take them back and he would grind these things up and he'd make transistors out of them and measure all of their characteristics. He's the only person I ever knew that spent something like 10, 11 years as a young fellow grinding up rocks and making solid state transistors and diodes and things like that. So he picked up a body of phenomenology that's, if you go to regular school and you just get the stuff, you're never going to have the phenomenology he ran into. So all in there is this background of absolute phenomenology. I'm not even sure there's a name for it. There's certainly no textbooks for a lot of it and everything. But he's got it in his fingertips, all that stuff he did as a kid. And they used to laugh and say, for a Christmas present, you don't give John a nice shirt or something. You give him a very interesting rock, ore samples. And he'll grind it up and play with it electronically. So he started off something else again. And when he got into making his amplifiers and all like that, by his own design, he made his own transistors. And the interesting thing with one of these Bedini amps is you could open up this amplifier and transistors were glowing in the dark. And parts of the circuit, the current ran backwards, didn't run the way that circuit theory says it's supposed to run. Electrical engineer or an amplifier engineer would open one of his amps and just go berserk and say, this can't be, you got this wired up wrong. And John would turn it on and say, well, you hear it playing, right? But anyway, his amps were good enough, and so good. By the way, I should say that he had an interesting background before that. He had some assignments with the Army signal people that were, special assignments where you're concerned with high security matters and all kinds of intercept communications and all. So John has quite an educational background in all of that whole field. Countermeasures, radio, intercepts, all kinds of things. Communications and communications intelligence. Encryption and decryption, the whole works. So he has quite an electronics background from the various trainings, and his early work was under some fellow that I don't remember his name, but he was one of these people that demanded, flawless work and demanded that you have a pride in your work and that when you put something together and you put it out, it's going to be a company product, it better be good. And he was merciless if anybody tried to take a laissez-faire attitude. So John went through a lot of work experience with working for a private company and all, where he was developing material and all, where that kind of discipline he worked under. And he's still that discipline today. It's all self-discipline. So if he starts to work on a project, he is so dedicated and so focused, he'll almost work day and night. But with the phenomenology that he picked up over all these years and all these things, he'll run across things that triggers, oh, that's this. It's not what everybody would think. And so pretty soon he's working in a fashion that the normal textbook guy can't even follow. And pretty soon he's got something working that when you sit there and scratch your head looking at it, you can't figure out how it's working hardly. And that's interesting when like with his motor devices, he was very interested in motors. You would watch, typical PhD that was, say taught electric motors and all come in, and he would leave in great frustration. He'd say, this stuff can't work. But if he was honest, he'd say, but the stuff is working. But it can't work. It's impossible for it to work. And some of them would just become angry, of course, and say, well, I don't even see that stuff. But he did awfully good work, and he got turned on to these motors and all early. Tesla, he got interested in Tesla stuff. And nobody ever told him he couldn't do it. He just started building little motors and seeing if he couldn't take out the back EMF and if he couldn't make the motor actually put out more than what he had to put in. And he already knew from all his other phenomenology he'd picked up from those rocks and everything else, he already knew that under certain cases, particularly solid state stuff, will pick up energy anyway. You don't know necessarily where it's coming from, but it's extra energy. Today, of course, we can talk about the heaviside component and some other things like that, but there was nothing in the textbook for a lot of what he was doing. He worked it out by trial and error that it works on the bench. And he has that whole background. I don't know anybody else that's done that kind of background. And then he would replicate other people's work. Somebody would say, well, nobody can build a gray motor. Well, John built one and it worked. He replicated it. Or nobody can make this thing over here work. And John built one and it worked. He's built probably over 100 working units of different types. A lot of his own designs, some he replicated of other folks. Incredible work that he's done, because that was his hobby. When he would work and build his amplifiers, his hobby was maybe building cars. He built a whole car one time. Fantastic engine in it. And his hobby was playing with building things like that. He loved to build new things that worked. He does his own machining. He's got all kinds of skills. And so he developed a certain set of phenomenology knowledge, even in his fingertips, so to speak, that The average technician just doesn't have on a bench at all. An electrical engineer wouldn't have it all. And he started building these engines, and he did, immediately, it was able to take out or reduce the back EMF. He was able to get them over there. And he noticed that pulses were not your normal breed of cat. Well, you see, if I read Prigogine and I read a really good thermodynamics book on non-equilibrium thermodynamics, I find leading Nobel Prize winners saying, there are certain areas that do violate thermodynamics. We know it. We reckon. Here's some of them. Page 459 in the book. Listen. And if you do these things, you are likely to be violating thermodynamics. And thermodynamics right now doesn't understand how that happens, but we are certifying that it happens because we've seen it happen and we know it happens. And sharp gradients, by the way, is one of those areas. So he was early on using sharp gradients. He knew that he didn't have to obey the second law of thermodynamics if he arranged that sharp gradient correctly. He also ran into the strange kind of energy he was getting in his circuits that worked backwards from normal energy. Today we would say, it's negative energy, and we'd have an explanation for it. There was no explanation when he first started this, except it worked backwards. It originates usually in the output and runs right over back to the input. It loves semiconductors. It'll eat them alive. All their little donors and acceptors, it'll just destroy them. So if you let it run back to the input section, it loves to eat electrons. That's one of the things. It doesn't radiate. There's no radiation connected with it. It's not para-annihilation at all. It's a different reaction altogether. But it will eat electrons. It'll run back to your input section, and when you're trying to furnish power into the thing, and you've got electrons you're furnishing, suddenly, let's say half of that's getting eaten up. The external power supply sees that as an extra load that has appeared in the input section. And it has to power that load before it has any electrons left to get to the regular circuit to power it. So it's sort of nature's way of collapsing, if you will, a system that's using negative energy and highly out of equilibrium, of collapsing it back towards equilibrium. It's a special kind of decay mechanism. Go over and eat the input. So once you find that out, and John got tired of having his input eat up, so he worked out ways he found he could collect that. And then he found he could change it back into normal energy where it wouldn't eat electrons. It turned out to be real hard. He charged a capacitor backwards, reverse the leads, reverse them back the other way, and they'll discharge normal energy. So by doing that, he started incorporating that. Well, he was down home free. I mean, a battery is, among other things, a great big old capacitor. And if you pulse charge a battery and you know what you're doing, where you stay away from the ground long enough to get the energy in backwards, and you get the pulse, which means you get a lot more than what you were counting on, you can actually charge the batteries. You can have two sets of batteries, like John's favorite trick. He'll charge one set while he's running the load off the other. And as this set starts just normal, there's nothing abnormal about the way he's running that load at all. There's abnormal about how he's charging this set or a whole bunch of sets of batteries. And as the primary powering set starts to go down, he just switches them, goes right on. He's always got a fresh charged set of batteries, the thing charged, and he's always powering it. And it'll run day and night, day and night. He had one unit that he put under the bench at Sylmar. He kept it under there for several years, and it just sat there running. It was one of these little motors. It was just a little bitty motor and its little bitty batteries, and it kept running and it kept the batteries charged. It didn't do anything else but run itself and keep the battery charged and keep on running. And it ran for several years.
I met Tom through a set of crystals, very early on, a set of crystals that we were producing in an oven, for the hi-fi industry, which is something that probably wasn't heard of at the time, because it probably was like a room semiconductor, for power transfer. And what we did with these crystals is we used them in the hi-fi industry to transfer power from the amplifier down these little thin wires about the size of your hair. And I sent Tom Bearden samples of those little crystals. Of course, Tom came back and, found it really interesting and came back with some things that it might have been. He was already on the path of doing this. I mean, he was, excellent researcher in this. And, of course, he sent me a copy of his book, and I looked at it and said, well, I've done things like that before. Because this energy field doesn't just take the crystals into account. It takes in all forms of energy that uses this type of radiant energy. So from that point on, it was development of motors, development of tuners, development of interferometers, development of just about anything one can imagine. I don't want to mislead anybody. The circuits are nothing special, right? They're very simple. There's no closed loops, okay? There's no closed motor loop. There's no magnetic gaps to adjust. There's nothing, okay? There's basically this one little circuit that fires itself through a magneto action, and you capture that electrostatic moment, you transform that, and you send it to the secondary battery. So you got two ways to do this. You can build it up in a capacitor, catch it, discharge it into the battery, and then you want to repeat this process over and over and over. But what you really want to do is you want to go as fast as you can without a capacitor, for the simple fact is you want to put a lot of this radiant energy to the source. And then you want that battery, which is the secondary source, to translate that for real usable energy, which runs your lights, runs your motors, runs your inverter, allows you to use the tools we have today. So whether you're going to capture this from this one little circuit, or you're going to do it like Moray did it, or Skilling did it, or Gray did it, however you want to think of how you're going to get it. Whether you're going to string up a long wire antenna and get it, it's there for the taking. Just requires the correct triggering. The machines that you've taped are prototype experimental machines to capture the radiant energy, to find out exactly what it is, how it works, what we can do with it, what we can't do with it, how much mechanical power we can get out of it without inputting more energy into the machine. And we have to state for the record that it's nothing that's new. It's not anything with this mystical halo around it, right? It's not that at all. It's always existed here. It's going to be here forever. Any circuits that we build, the engineers are going to want to get rid of it in the circuit so that the circuits don't just burn out. You can see it show up on the scope. You can't measure it with a standard meter because the standard test equipment is only going to measure electron flow. It's stuff that's thrown out of the system. Stuff that's wasted. See, what you're measuring with the meters is everything that the circuit is wasting. So that's in terms of heat. That's in terms of current flow. That's in terms of everything that looks perfectly normal to you. Because these are the instruments we have. But with radiant energy, we don't have any instruments. We can see it. We know it's there. It shocks us. It does little things like that. It lights neon bulbs between the earth and plastic. Yeah, it's very, very obvious that there's some form of energy there from the vacuum, right? That we really don't have instruments to measure, and the only thing that we do have to measure it is this gas indicator that glows. So we know that in a way it's fluid. It's like a gas. And so what we need is something to convert the gas to electrical energy. And we're not talking about a fuel cell here. The battery is the only thing that I've found after 40 years of research that can convert any of this radiant energy for usable power. We had a little trigger signal from this battery over here, and that starts the motor, which we're going to do right now. And if you come around to this side over here, you can see over here, we'll slow it down a little bit. Over here, it's magnetically triggered on this side. Come over here. So each time one of these things goes around here, it puts a little trigger signal into these coils. And once we get the trigger signal in there, then what we can do is we can, each time this triggers, turns on and turns off, we can collect the charges that would normally be wasted. And of course they go into these banks over here, these capacitor banks, and then this is a timing mechanism here, which it's timed to be about once every second and a half or so, and makes contact here after we collect the charges. And then these capacitors here are dumped through this electronic switch here, and you can actually see the dump here. You watch it and it'll bounce up when it dumps. So if we slow it down a little bit so you can see it. See, it's bouncing around here. Each time that dumps down, the capacitor bank discharges into this battery. So this battery is going up, and this is basically a 12-watt motor. So it's got a little bit of torque to it here. And basically this is what led us to do the bigger motors and how to collect the charges so that we can recharge the batteries on our other motors. And so then if we look at the principle of the way this one works with charge, discharge, charge, discharge, charge, discharge, we can take it up in models. We can move this up to a much more complex machine. As this mechanism triggers here, these are coils. Okay, so the first thing that happens is it wants to repel the magnet like you see it doing here. Okay, it's because it's turning. But these are tri-Fowler wound coils, meaning that they work like a transformer, but it's not exactly a transformer because they're one-to-one. So the only thing that can go through this transformer is the radiant spike. And the radiant spike is collected in these condensers. The critical thing is the spike. It's been the spike all along, the exact replica basically of a nerve impulse. I mean, the nerve impulses in your body are not there for no reason. And if we put the meter on it here, so you can watch it, you can watch how the spike is collected. You see? It goes up and down because it's charging and discharging. Now watch, we'll switch condensers. And this one will charge slower. See, and you won't see much of a discharge. When we move to this one over here, it charges much faster. And so the battery is always seeing this 19 volt pulse to it, which then the battery translates it into real energy. See, the battery's now at 1280, 82. See, go to 90, jump up to 90 there. Once you understand the principle of the machine, of how it operates, then you can move to a bigger model, which makes this principle go faster and faster and faster. So now the energy is recoverable real fast. In other words, we want to recover this energy as quickly as possible to the battery. The energy from the vacuum is triggered by the radiant. You see what I'm saying? In other words, when you hit that battery with a radiant energy, the battery takes the energy from the vacuum in the chemical process and converts it to something that's usable at a later time. In other words, it's a triggering mechanism. You have to trigger your circuits to produce a radiant spike, and then the radiant spike, when it hits the chemical action, sucks the energy from the vacuum. And that's what's charging the battery. You know, the term free energy is probably the most misused term in the world. The term that I would use is free radiant energy. You see, you want to make up the radiant energy, and you want to do it for the least amount of power input. So what you want to do is have the circuits translate the normal power into a radiant energy. Then you want to capture the radiant energy. Once you capture the radiant energy, you transform that back to something that's usable for the battery, see, which is a radiant DC. And the battery then after that just charges like mad. So it's all translations. So now we're going to expand on this thing. So here's the battery. Listen very closely here. That's the oscillators running the machine. You see it wiggle? Now watch. That's because there's no output hooked up on it. So now what we want to do is we want to take this dead battery, and we'll get this thing to go here. See that it changed in tone? Now we're going to tell it to go. And we're going to watch over here. This was a completely dead battery, and you're going to see what's coming over here because now we have told it to charge the hell out of it, see? So see, it's up to 24 volts already. So this was a dead battery, so what we've done is we've increased these pulses now 8 times the amount. So what this battery's doing is charging itself up, and you can see that on the meter there. And so now as this battery starts to charge itself from a dead state, the impedance in the battery will drop down, and you'll get current in this battery. You'll be able to light a light here in a second. By the way, there is no RF used in this machine, but I want to show you that the energy in the primary battery is definitely there. And so if we were to just stop this for a second, we don't want to get our hands in there, and we put these lights in series, you don't see, remember we put this in series so that the energy has to flow through these lights to the battery. So now, if we look at the battery, see the same voltage is there. So that means that the energy, and if you look at the lights very closely, as the battery changes impedance, the lights are starting to light. See, now let me take one of these off so we'll get it down to a level where you can see this, just by disconnecting one bunch. See? now this is over the top, this is 8 volts over the top of the battery. Okay, so you see, as this battery lowers its impedance, these lights will get brighter. Okay?
What's causing the impedance to be lower?
The energy that comes from the machine is trying to charge this dead battery, which is driving the sulfation off the plates. So now you're starting to return to a normal battery, see? So after charging this battery, okay, in the short time that we did, we should have some indication right now of current in this battery, and we do. The battery now has energy in it. See? Now if you notice one thing, we didn't have this running all that long on the battery, and the battery now is saying, wait a minute, where did I get this energy? This is a dead battery. Okay, so let's let it run a little bit longer. We expanded the machine, so we made it on a 2-tier level. We wanted to see what if the small wheel was exactly like the big wheel, and it's identical in output. We wanted to make sure that the problem wouldn't be in geometry in the end. Okay, so we built the big one first, ran it, tested it, just like we're doing right now. If you look here of what's coming to that battery, see the pulses? They're faster and faster and faster as the machine goes. Pretty soon it's steady. See? That's the energy that's going, that is the spiked energy, or the radiant energy that's hitting the battery. And the battery, being that it's a chemical reaction, can translate that into energy. See, it doesn't make any difference if the battery's been sitting 2 years or 5 years, or what the sulfation is on the battery. This energy doesn't care, it just breaks it off. After a radiant charger charges batteries, it's a little more difficult to charge with a conventional charger. It takes a longer time after that. So there is an alteration that takes place from using this form of energy that takes place in the chemical composition of the cells. You know, and once it's attuned to this way of charging, the battery accepts the radiant charger much faster each time, higher power density output each time. So a 33 amp hour battery might look like a 65 amp hour battery. The difference is radiant's one form of energy, EM as we use today, electromotive force energy, isn't capable of charging this sulfated battery because it sees nothing. It sees an infinite resistance. Okay? Radiant energy doesn't, being that the energy is like 100 times or 200 times what the sulfation process is. Here, you can look at it again. Now it's brighter. See? And it'll keep doing that. The sulfation will come right off the plates, and the battery will become a pretty good battery again. We have another example of that machine over there. This is a monopole motor, okay? This is a monopole motor, and this is in our US patent, and you can find that on my internet site. And this motor over here is what we termed as the motor generator. Quote, that's what the patent office, and the patent examiner and everybody decided it's a motor generator. So, but this showed us the original process to get to this motor. This is an advancement in what the energy is. And what we found out is when we apply conventional electronics to it, you don't get the same radiant output. So we have to go unconventional with this being, and that's why we call this the monopole. Because you see that it's all the same magnetic forces all around the wheel. It's all north poles. And each one of these is on its own independent circuit. And then they're all collected in the end and sent to the battery continuously. So there's no need to do any capacitor, anything. There's no capacitors anymore. See, you don't need to do that if you collect all the spikes and let the battery translate it. This is like a standard alternator. In other words, each time that this, I don't want to get my fingers in there. You can see here that there's 8 magnets. 1, 2, 3, 4, 5, 6, 7, 8. They're all North Pole. There is no South Pole. This motor does not switch back and forth. It is, and it's an attraction motor. It's not a repulsion motor. So every time that it's attracted in, it fires like a magneto. Then the electronic circuitry decides to fire, but see, it's out of range when it fires. It's at like 23 degrees after. So when it fires this field, the field is big and pulls in the next magnet, and it repeats the same process. So we want to do this as quickly as possible. So you see one pole here, one pole here, one pole here, one pole here, one pole down here, one pole down here, and we want them all to fire at the same time. So if you look, all the magnets are lined up to fire at the same time in this direction, and then when the motor moves over here, all of them are lined up to fire in this direction. Once we do that, this is what we can do. Then we got a self-pulsing motor with torque. We're generating what I term as a magnestostatic impulse. In other words, what we want to do is use the magnet to charge the iron and then have the iron discharge itself, generating a pulse, like a magneto on a lawnmower. This is just a simulation of how the motor pulses. And pretty soon it's over the top. And this one here, you see, is just the same motor, pulse motor. Let's get it. Once it generates that pulse, we want it to turn on the device that's making the magnetic field, so that the next pole coming around can be sucked in to generate the next pulse. But meanwhile, before the pole ever gets sucked in, this radiant energy appears. It's in the switch. Just as you throw the switch, the radiant appears. As the current comes through the switch, the radiant disappears. So we want to capture that before the current appears. See, if you turn it off before the current appears, you can't burn any energy. Remember, the current's behind the potential, which is the dipole. So when we short the dipole, the current appears. We want to take advantage of cutting that off before we kill the dipole. We want to tap that off to the secondary battery, because then another dipole appears. Here's the example. If you just put this battery to another 12-volt battery, you can only divide the charge between the two batteries. So therefore, you have two lower batteries. But in this thing's case, this 12 volts right here is only to trigger this. What comes out of here is the radiant spike, which is about 4 or 5 times over this battery. See, because now this battery, in other words, that's charging it with no current, basically. And you can see the battery has charge in it because it's barely flickering. So even if we stop the motor, see, The battery is going to go down to its original voltage. If we start the motor, you can see the pulsing process starts and the lights start to grow brighter. So where is this energy, right? Where's this energy coming from? Well, it's coming from the collapsing magnetic fields, right? Which produce a radiant spike. And see, most engineers would take this circuit and short that out because it's not necessary. So they throw away the radiant. That way, if they throw away the radiant energy and don't capture that radiant energy, what happens to this battery is it just gets depleted. Since radiant energy doesn't care, you might as well just stack up as many batteries as you can and charge them all, since it doesn't care how many there are. That's why all the machines I've always shown have shown one primary battery and 4 parallels behind it. You know, at any point in time when my primary is exhausted, I can pull one out of the 4 and put it back there and insert the other one back in. I can loop this system. And this is without closing the loop. These all run on a C20 rate of discharge. So whatever the amp hours is in this battery, it'll be on the C20 rate of discharge. So you'll take, if this is an 18 amp hour battery, you'll divide that by 20, and that'll tell you how long you can run this at how much current. And that's how all these are done. But that's not saying that if this runs 6 hours, that this battery, see, we haven't been running this that long. This battery's been dead for a couple of years, okay? And it's already got a charge in it. We can do all the front end conventional. We can tell you how long this machine's gonna run. What we can't tell you is how this back battery is gonna respond. And obviously, the COP of this machine must be pretty good because this was a dead battery. You saw it being measured. And see, now it's holding its current. The COP would be about 18 to 1 here. In other words, if you correlate, you know, what you're putting in. And so we have no measurement technique except for the scope. Okay, we can measure, we can see the radiant energy, and since the meters won't respond to radiant, okay, we have no way to measure it, but we can tell you by the work that we get out of this battery that it's around anywhere, the lowest minimum is between 3 and 18. In 1984, I attended a conference with Tom, but before that point in time, I'd written this little book because I had done the experiments. This is what the phone calls were all about with Tom. I'd done the experiments in the lab and successfully built, you know, this motor that ran itself and ran itself and ran itself and ran itself, and then was basically operated like a flip-flop system back and forth. And I got invited after I wrote the book. Actually, I think it was the Tesla Book Company actually paid my ticket to go to the conference. And of course, to my surprise, you know, I was already working on other circuits after that. I was working on the 4 battery circuit that switched back and forth and kept the load going. And of course, I never suspected that during that time that this guy by the name of Jim Watson was ever going to show a machine this size. You know, 12 kilovolt machine. He bought the book and constructed a little design of this, got it to work. And then, of course, the next time I talked to him on the phone, they were, you know, when he said that he was buying an aircraft starter motor to turn this 900-pound flywheel, I just said to myself, whoa, wait a minute, stop here. You know, what's this guy going to do? What's this machine? How big is this machine? You know, so the Tesla conference comes, and I'm there. The curtain opens up, and I'll be damned if there wasn't this machine that was 20 feet long, you know, by about maybe 15 feet, 16 feet high. You know, the biggest flywheel you've ever seen in your life, probably a shaft that was this big in bearing blocks, and he just hit the button, and this thing just wound up, and all as you heard after that was click, 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 and it was recharging its own batteries. And of course then, you know, the Tesla Book Company went out of print. Nobody could get any of their books out, including Tom. No one knows what happened to all the information, but it looked to me like it was just conveniently bought up and buried. You know, now think about this for a minute, because if these machines started to exist after a little story book was put out by the Tesla Book Company, I call it a storybook because basically that's what it was. It was about an experiment. It showed all this basic stuff, and it said you could make the machine like this. I had a laboratory model of it, which was later on disassembled completely. Actually was cut apart by different people, you know, which is a sad thing because they don't believe you. They have to come in and measure for themselves. They have to cut things apart. They have to take wires and move them over here, and pretty soon the thing doesn't work anymore. So I just say that, you know, after seeing this big machine, you know, that comes from this little storybook, it becomes true that what you read about in a book, you can build. You know, providing that you have the knowledge, you know, some skills to do it. And anyway, this machine ran throughout the whole show. And later that night at the Tesla Symposium, they stole the batteries from the machine. Somebody did. So the machine wasn't runnable after that the minute they stole Jim Watson's batteries. You know, of course, I understand why they stole the battery. Because any machine that uses that type of energy that charges batteries like this, you can definitely get an indication that the battery has a lot more power in it than what the normal battery has. I could give you an example. I could outfit a submarine with its standard batteries and standard equipment, standard charging system, and the equivalent would be I could also outfit a duplicate submarine with a radiant charger built for proportion to the batteries, and I guarantee you that the submarine with the radiant charger could stay down longer, the lights would be brighter, while the other one had already surfaced. You know, there's just some effect that takes place, and today we know more. Today we know more exactly what this energy does in the battery. So there is an alteration that takes place from using this form of energy that takes place in the chemical composition of the cells. You know, and once it's attuned to this way of charging, the battery accepts the radiant charger much faster each time, higher power density output each time. So a 33 amp hour battery might look like a 65 amp hour battery in terms of its output power. And this is where the real gain is. It's in the chemical makeup of the battery. You have to trigger your circuits to produce a radiant spike, and then the radiant spike, when it hits the chemical action, sucks the energy from the vacuum. And that's what's charging the battery. That's where you're getting the energy from. Okay, so it works like you do. Where do you get all your energy? Do you think that candy bar you just ate gave you all the energy? No. You run on vacuum energy. You know, look at the work you do. If you tried to do that electrically, the battery a long time ago would have been exhausted. This is your typical monopole motor, okay? You only see one pole here. You see, you don't see a north and south push-pull motor. You see a motor that's totally in attraction here, that's a magneto. So what we have here is a magneto radiant generator, basically. We come in with this magnet, we charge the iron. When the magnet moves away, that discharges, fires the transistor. The transistor then fires the coil. The coil then does a flip-flop, generates a radiant spike, and the diodes collect it. And then it's sent to the battery. What you're designing here is an energizer. You need to take what little bit you got in the front and be able to charge these for use. That way you can sit here with the motor that's off until you need to run it, and it can still be connected to the battery. It's not doing anything until you need to use it. The monopole motor is not a self-starting motor. It's like a lawnmower engine. It's like you wind the cord around and you give it a pull. We don't want to make these self-starting because that takes energy. We don't want to waste any energy in the primary circuit. If you were to make this a commercial unit, you'd have a starter just like you have a starter on your car. You'd push the button, you'd let go of the button, the motor would be running, and that'd be it. So you can sit here, once again, on its voltage without drawing anything. Nothing. See? In other words, if the transistors were on, it would just push it out of the way. In other words, the magnetic field would be there and it'd just move it to a point to where it wouldn't lock. So you need to run a magneto here, see? A magneto action to make it start. And it's very light start here. See, look. This is going to be the input power here. This is a monopole motor, the same as that motor, but now it's horizontal instead of vertical. You follow me? The monopole motor, you can turn it on and nothing is drawn. So it can sit on its batteries. Now the minute I say, okay, go ahead, let's start, you can see the current right here. You see it go through these two peaks? Let's slow it down so you can see it again. See there? Watch. See how it just dropped off? Now it came back. Right? Now it says that it's drawing 1 amp. Okay, so it's drawing 1 amp, and these are 50 amp hour batteries. So that means that we're running somewhere on the C25 scale, which means we can run days, hours, okay? Now, at the same time, we're charging these batteries over here. Okay, now, as I ask this motor to do work, watch. It draws less. Now watch here. Let's ask it to do some work here. We saw that it was just a little bit over an amp at 24 volts, which is 24 watts input. Now we're going to say, just drive this fan, right? And let's see what the current is. So watch over here. Okay, this is really doing work. You see it went up to the 1, and it's going to drop down. See, it's not drawing any more power. So if I tell it to do more work, it's going to draw less. Watch. See?
Positive energy is divergent. And remember, pointing only got the diverged part that comes into the circuit. It's the divergent energy. It's always trying to diverge from its line of flow and escape back to the environment. It's trying to get away from where you want it to go. So what we call conductivity, like in a conductor, is the characteristic of that conductor to be a waveguide, to prevent that escape of positive energy and hold it along its path. So if I have perfect conductivity, I don't have any loss. The energy is forced to hold in place and gets across to the other side. I get just as much out as I put in. But normal circuits are not pure conductors. We have impedances. Even in the wire, we have a little impedance. So what we have is we have an impedance that is met along the path. An impedance, by definition, is a small reduction, at least some reduction in your conductivity. That is, it reduces the ability of that wire to be a waveguide and hold that energy along it. So some of the energy escapes and leaks off. And we call that losses in the circuits. So for positive energy, I put some in at the beginning. I have my impedances. Certainly if I got a load, I've got impedances. But I've got impedances in the way my circuit is made anyway, and I'm losing some all the time. So I'm going to get less out there in that load to power it than I put in. It's the leaky diode, leaky pipe. The pipe carrying the energy to this load leaks all the way, and I didn't get as much over to the load as I put in. Sorry, I'm under unity, particularly since I got it in a closed current loop circuit and I'm killing my power source with the other half all the time. But negative energy is nature's beneficial grant to humankind and to the world. Negative energy works exactly backwards. It's the convergent energy. It's the energy that the environment is always trying to pour into any flow of negative energy going along a conducting path. The environment is trying to put more negative energy in there all the time, free. You don't have to pay a thing for it. It's trying desperately to do that. Conductivity now is still the process of preventing change and of doing that waveguide and preventing any change. So the negative energy flowing, well, the conductivity will not allow any excess energy to flow in there. And so in this pipe, I will now get out pure conductor. At the other end, I'll get exactly what I put in, just like I did with positive energy. But again, it's not a perfect world, and the circuits are not perfect conductors. There are impedances. But now when I meet an impedance, what it does reduces the conductivity, reduce the wave guiding, which means some excess energy now crowds in here and converges in here, negative energy. Coming past that impedance, I have more than I'm putting in. The next impedance, I get some more. So if I have a series of impedance, by the time I get to the end of the flow, I have enormously more flow than I'm putting in. 10, 15, 20 times more in a common circuit. Maybe 100 if you really do things real fine. So I have lots more negative energy coming out than what I'm putting in on the other side. I didn't create any energy. Nature kindly gave that to me because she said, oh great, you allowed me some impedance where I can give you the energy. And I'm happy to do that. Here it is to you for free. And you say, well, we got to have positive energy to run loads. Well, we do with the way we design them. We could design them to use negative energy, but nobody's ever thought of it. Nobody's ever developed negative energy flows, except one fellow named Bedini. And so nobody has paid any attention to using circuits in the negative energy role rather than a positive energy role.
That's the way that the monopole motor was designed. It was designed to do absolutely everything opposite, because when you do everything counter what our rules and regulations are, the result output is high radiant energy. We push the circuits with current flow in the front end because we have to do it that way to make it switch. So there's very little current being used, somewhere on the order of 300 milliamps, not very much at all, to create the switch. After that, nature supplies the energy in a radiant spike, which can be termed either radiant energy or energy from the vacuum. It's an automatic thing that takes place with a coil of wire. There's the field that grows and the field that collapses. The collapsing field contains the radiant because there's no current. If you don't have the current, you got radiant. If you have the current, you have no radiant. So the skeptic is not willing to look at that. Okay, so now we want to look what's going to this battery. And so we're going to use 4 of them to go to 24 volts. Okay, so now we're at 24 volts, right? And let's actually see what we got here. Okay, it says between all these batteries, they're at 14, okay? Okay, so now let's see what we got over here. See? It's outputting 23 now. So it's actually building this up, see, to charge this 24 volt system. Now we know that this system is the low side, right? So what we would do is stop the machine and just take these two and reverse it, okay? That's the primary battery. Now we're going to look at the secondaries, because now we've got this battery undercharged. Look at how quick it got it there. The monopole motor self-regulates to the load. It automatically servos itself to the load.
If you were to measure the transient voltage of the spikes,
200, 300, 400 volts. It's all a trigger process of sucking it completely out of the vacuum. Electronics, they short that out. Well, they'd have to filter it out or the devices burn out. There is no transformer makeup whatsoever in this motor. This is just a trigger. See, now it's got this battery up to 24, 8, 9. Going to move up. See, you notice that it was at 25. It came down. That means the impedance is changing in the battery and the battery's taking the charge. You understand? When the battery is dead, the impedance is high. And when the battery becomes undercharged, when it starts to charge, the impedance starts to drop. When you reach the lowest impedance of the battery is charged.
is this also true in this condition that as the impedance goes down, the amount of current to the battery goes up?
Right, exactly. Right, but see, then the voltage rises all of a sudden, and the battery's charged. See, it only does that under off-gassing.
Off-gassing?
Yeah, we don't want to produce any gas in the battery, because then you heat it. What destroys this battery is heat. Pushing a lot of current to it for a short period of time, trying to get the charge there. This process is natural, like nature. Nature takes a certain amount of time to charge its battery. See, you can't cause nature to move faster than what she wants to do. In other words, when you push a lot of current to a battery, you're forcing a chemical process which nature says, I really need this much time. You follow me? So she's going to buck you and she's going to fight you. And she's going to cause heating and gassing and bubbling and loss of electrolyte, which is just killing the battery. You know, where a radiant charger comes in, nothing boils, no gassing, coolness in the battery, and this charger is just going to charge on nature's curve. So as long as you follow those rules, the battery will charge, and the primary battery, you can reverse this process over and over. You can do this with dry cells, you can do this with gel cells, you can do this with, these happen to be gel cells, could be plugged into the wall and burn 1/3 less. This could be running on a solar panel right now in the sun and performing this process. You see, that way the solar panel doesn't have to boil the battery. You could design it so that it could switch its own batteries and run it until the bearings wear out. This is where the term perpetual motion is not true, see, because something's always going to break. Yeah, so you can't call it perpetual motion. How do we know when the skeptic comes to us that it really is 1 ampere of energy? Whose law is that, besides Ampere's law? You know, that was an invented thing, widely accepted because the compass needle went this direction. Well, that must be 1 ampere. Yeah, well, of course. It's repeatable every time. Well, let me tell you something. Radiant energy does the same thing. And there's no amperes involved at all. You know, the galvanometer, which is, if you look at our test instruments, what is it? A voltage meter measures potential. What is a current meter? It's the same meter, except now you've put the energy through it to deflect the meter. On a scale, it's like the Gutenberg press. Is this the Bible? I don't believe that it should be called an ampere at all, because I really don't think that anybody can explain to me how they got the ampere. You know, there's all these theories floating around. Well, there's electrons. How do you know that? Have you ever seen an electron float through the wire or on the outside of a wire? You don't know. But I'll tell you one thing. The etheric flow, or the radiant flow, is definitely on the outside of the wire, and it's a gas. You know, it's something you can detect with a gas. It'll light it up. This frame is completely isolated from these batteries that we're charging with this charger. That's the signal on the battery. You're looking at the radiant energy to the battery. That's all there is going to the battery. And so if I take the clip lead, and we know that this is independent from the batteries, and you can see that the energy is on the plastic here of the cap. See? I'm not even touching that, and believe me when I tell you that this is radiant energy, because you can even remove this, and you can, yeah, you have to make a connection to the ground with this. There, you can see it. It's very dim, but you can see it's actually flowing through the ground here. See? It's very dim there. But see, the frame is isolated from the batteries. In other words, these batteries are all independent all the way around, and we are limiting
So you're touching plastic?
Yeah, I'm touching plastic. See, and anywhere I go on this plastic, if I go over here, it's here. If I go over here, it's here. If I go over here, it's here. If I go here, it's here. If I go here, it's here. If I go back to this cap, it's here. Okay, so I can go anywhere around this battery and find out where the radiant is, see? Just by going from cap, see, not much there, a little more there, see? That's right on the cap.
And if we turn the charger off,
Okay, I'll turn it off. Yeah, because this is not electrically connected to the batteries at all. That's not connected anywhere. I don't care where you go on the frame. You know, these are isolated terminals because they have to be on a golf cart. So, who's to say that the skeptics' instruments are correct? It's something you can go buy at your local store. Look, everybody's got one. Yeah, everybody's got a voltmeter, everybody's got an amp meter, so that's what it must be. You know, and as long as you stay in those parameters, you never can get outside that box. This is off our master. This is off our master patent, and this has got one sense coil, and the rest of the coils are all slaves all the way around here. And what the machine has to do is these, if you come a little bit here, you get close here, These are special magnetic poles. They're two north poles. They're pushed together to form a sharp north that Bearden talks about, forms a scalar north here. And what we want to do is we just want to turn the sense on, which is this switch back here. And you can see the voltage here. It's got them up to 2486 already. Those batteries are out there, the 1800 amp hour batteries. And so we just turn the switch.
Can you explain briefly what it is we're doing here, what it is we're looking at?
Okay, we're going to take one bank of semi-charged batteries, and we're going to put the energy into another bank of batteries. Then we're going to draw off the energy over here on this panel. 2.4 kilowatts is what we're going to take.
So you got a source battery.
Yeah.
Where are those?
Okay, they're around the corner on the other side. Source batteries are right here, and these are pretty well up to snuff. These are low. Right now we're going to charge these batteries here. We're going to charge this 1600 amp hour battery, and then we're going to pull off the power with the inverter.
And all these batteries are hooked together.
Yeah, they're all hooked together. So we're going to charge them all at one time.
And this is our source battery.
This is going to be our source right here. We want you to watch that we're going to be drawn. We're going to put about 10 amps into this machine when we start it. So we're going to start the machine right now. And how you start this is it can sit on its own battery, and you just give it a trigger, and you can sort of hear it. And you can watch the current here. It's going to shift 2 times. So it goes into resonance, and then it's going to draw the full power. Meanwhile, those batteries are starting to rise.
Now what's this meter reading?
That's reading the batteries we're charging right now. Okay, so we're almost up to power now.
So I'm looking at about 8 amps, 9 amps?
Yeah, you're at 9 amps now. This is going to maintain its speed, and if you look on the other side, what's governing the speed is it's generating its own power to run the trigger, and that's this light back here that you can see. Okay? That means here's the wave. So you can see what the wave looks like. These are the radiant peaks that are escaping from the coils. That's what's charging the battery. So we bring this down a little bit. So we bring this down so you can see just how high they're off.
Spikes.
Yeah, they're off the scale there. Okay. So it's got them up to 2504 already. I'm just going to be pushing them. So we're just a little bit under, well, we're just right at 10 amps right now. So this is the draw off the bank we're drawing the energy from. This is the trigger voltage. You can see the trigger voltage is right here. So we're only using about 20% of this current to run the machine. And you hear that little ticking sound? That's the snapping of these coils. The trigger coil itself is making the snap sound. Yeah. So what you got here is a big rotary magneto type device. And what we do is we pick off all these little spikes and we rectify those spikes, and that's the potential that's going to the battery to charge the battery. So I already got it up to like 2520 now. If we run this without the load, it would destroy the circuits. Yeah, that's why this little sign here, make sure output is connected before starting. Because it's so fast, the radiant spike is so fast that it just takes the solid state devices and pops them from the center out. we wanted to see in the beginning if we could affect the charging by adding more current to the input, and it doesn't. So they're multi-band coils. You can see it here in the wires. And these bus bars are actually conducting the energy on this side out through these big cables. See, our input wires are relatively small, and our output wires are relatively real big. So this machine will go. We'll show you that it will go either way. Okay, so now we turn the trigger on. And you can see when it starts up, see it's off the scale. And these are all multiple firing, so as soon as it gets in sync, and you can tell when it gets into sync, this light will be at its brightest. And this is the actual on time right here. About millisecond and a half on this. And you'll see it'll go into sync now. We'll expand one out for you there. And we call this the H wave. Looks sort of like an H. We wanted to spin this backwards, but we're going to let it go in the clockwise direction. So if we were going to take the power, we can do a quick measurement here. If we want to take this power now, we have to disconnect this to take the power.
You want to wait till this runs down?
No, I'm done. Okay, so we're going to have to hook these in here, and we'll just test these cells. Okay, so we ran the machine, and this is going to be backwards. So it says it's at 1262 at 100 amp hour test here, and we're just going to test it and see where we're sitting here. Then we're going to take the power from them and then put it back. So they've got 96.24%, see, 96.24% capacity, which they didn't have when we started. If we go and is we want to take bank 2 and take the power off them. Yeah. And that meter is really spinning. And so you can see we're really loading the battery system down, because you can see where the meter is from where it was before. And we're going to put that back. And see, you can take whatever power, and you can watch here the load just in standby operation. You see? So now watch as I switch on the loads. You can see we're really going to take the power out of them. See? For all practical purposes, you can just plug in what you want within limits of the inverter. Yeah. You can see it there, and you can see the increase on the meter when I turn it on. See? That's real power. So now let's put this energy back. Kind of got a snap to it, doesn't it? And you can see just what this energy, how quickly this energizer is going to raise these batteries up, because you can watch it here. It's barely turning down, it's already starting to raise it. See? And that's the whole idea of this project, is to transfer energy, you know, to be able to use the power, then use the primary bank to replace that power, and do this several times. I mean, we don't have any solar here. We don't have any wind. So what we want is to get this bank up to standing as quick as possible, which is just about there now. And see, it's starting to raise it pretty quick here. So then I'll do it again. I'll pull off the power again. I'll give it about 15 more minutes and I'll pull the power off again. It's feeding. This is a potential charge. There's no current in this charge. 100, 200, 300, about 400 volts radiant spike on each one of these. And what we're picking off is this spike, and that's what's doing this charging right here. So there's no current in this spike. So it's just a potential charge. The current's on the input. And by limiting the current on the input, you get a better radiant output. We took 2.4 kilowatts for what, about 5 or 10 minutes there. Okay, but that's a lot of power. Yeah, and so it, you know, you can't, this is a 24 volt system, and to suck it down to 23 volts is like putting a load on it. But see, here's the whole point. The whole point is to use the primary system as long as you can, to use as much, get as much as you can out of the secondary system. Then to put a battery in reserve to run back and charge the primary, which we can do that now. The batteries, if you buy them new, are $3,000 each cell. If you buy them new. If you find them surplus, they're about $65 a cell. But that's what it would take, basically, those two banks to run your house. You can run this one day off solar, which works real well, or you can run it off the batteries when you have no solar. See, that's how this system all interfaces. Yeah, it's crawling up there. It's 20 magnetic poles. 20 magnetic poles and 10 electromagnetic poles. So there's this imbalance, because we're trying to catch as much of this stuff as possible. So now we'll disconnect and we'll go out and measure again. Okay? We'll just go out and measure that bank again. 93.75. Let's see, we brought them up pretty quick from where they were. I think we were at like 94, right? But we only went up to 2502 on this one. So let's just take the power again. So we'll just take it again. There it is.
Would you sell this to somebody if they wanted to buy one?
No. It's the research. But we got that project on the internet and we told them how to do this. It's on the Monopole group on yahoo.com. That's how you do it, boys. You just go back and forth with them. We're pulling as much as we can pull out of it. I mean, this is no problem at all. Those are real 100 watt light bulbs. We can run this whole shop in an emergency. You know, we lose power here, we really don't lose any power. We've got to.
You ever done that?
Yep.
Have you really?
Yes, we have.
How long?
8 hours. Gary and I ran all the lighting at the other place off this. Okay, so we'll set the machine into motion and let it just recharge the batteries. Tesla is absolutely right on the button. You know, Tesla is one that, of course, at that time probably started inventing these strange terms. You know, inventing some term like radiant energy. Okay, what is that, guys? Well, see, Tesla discovers this because the people that were running the DC generators at the powerhouses, threw the switch, the wire glowed, killing the operator, and as soon as the current caught up, the glow went away. That's the energy that we want to capture. That's the radiant energy when the wire glows and then collapses back. Those generators were probably at 20,000 volts. So when they threw the knife switch, now just think of this for a second. There's this big inductance. There's this wire that goes down to the end. You throw the switch at the powerhouse, the voltage is already there. That's the dipole. Well, before the current can get down the wire, this wire is emitting great big gigantic lightning bolts that killed the operators. So they had to damp this out some way. So what I've just told you about the radiant energy is exactly what our engineers do. They kill the dipole. They short out the radiant and just use the current. And of course they measure the power then in watts. I'm the opposite. I say, let's find out where the source came from, how it got there. Let's learn what nature's process is right here, because nature will give you all the watts you want if you transform it. So back to Tesla. Tesla was probably a guy that was like 200 light years ahead of his time. I mean, look, the guy invents... Look, he was the only guy that would sit in 100-foot lightning bolts. I mean, what was he doing there? He was studying the gas, the etheric gas, because he said it was a gas. Yes, he knew. He knew because he was a great studier of the experiment. You see, do we really do the experiments today? No. We just build what they tell us to build. We don't do any more experiments. You know, we don't learn from our experiments. We don't learn from the observation. You know, it's already in the book. It's been done. Don't waste your time. Here it is. These are the formulas. Learn them and you'll pass.
We see these pictures of Tesla sitting in a field of electricity.
Yeah, but that's etheric energy. That's exactly what nature would provide.
Not the lightning bolt that would kill him?
No, the lightning bolt will definitely kill him. Okay? That's not the point. The point is, how did that big of a lightning bolt get from that small of an input? Unless he was tapping something. And that's what he was studying. The flow of etheric energy. When Tesla saw, you know, this gaseous cloud come out over his coil that would penetrate everything and sting you at a distance. You know, that's etheric energy. That's the energy that makes up the electricity. What I studied of Tesla was everything that he possibly has done that I could get a paper on. I read his lectures. I understand what he was talking about by the way he wound his coils. I understand why he said you could build coils that had little capacitance or a lot of capacitance. But the main thing that I studied the most was, what is the distribution of capacitance in these wires? Because that's what led me to build these machines, is because just by reading what Tesla's talking about there, one knows that any electrical circuit, no matter how powerful it is, that the radiant will appear first when the switch goes on. So you have to be able to steal that. Yeah, see? Tesla gave up the idea of alternating current and went to pulse DC. That's where the power is. PWM. Pulse width modulation. Anything that you pulse, you can get an extreme amount of energy out of for a microsecond in time. Yeah, so it becomes efficient, right? It's not always on and it's not off. So the battery can't react fast enough with the current to be used up if you do this method. And you can capture it and send it to the next battery. This is what Tesla was about in the end. I don't know what the batteries were that Tesla had, or if he even used batteries. I think he was more towards the end of shaking it out of the vacuum and lighting light bulbs, which he did successfully. Okay? And running specialized motors that he developed. All right? Because he already had admitted in one of his lectures that putting iron in a motor was not a benefit at all. It was something that just made the motor heat up and lose energy. Because he had stated that. Early version of motors, it's still used today. It consumes energy, heats up. Anything that causes heat sooner or later breaks down. Totally wasteful. If you want a measurement, heat is fine. Yeah. You can measure the work by the heat. You see? But it's the stuff before the heat that you're really interested in. As I said to you in the beginning, these are archaic tools to work with compared to the technology that you're dealing with. Okay? When you're dealing with an energy that's emitted from the vacuum, you're dealing with something like a gas flow. Totally different set of circumstances. Now, Tesla did say that he had math for it, but it never appeared. These batteries go right back down to standing, and we're going to test this battery at 100 amp hours. And it says there's 90% capacity in it. And then we're going to take power off and at 100 watts. We're going to take it off. So we're going to time this out to 5 minutes, and then we're going to ask the machine to put it back in 5 minutes that we take out. And we're going to do it from these little bitty batteries, and you can see the size compared to this battery. So there's no possible way that this battery can charge that big one. But we'll take a measure of those right now.
So we'll let the light go for 5 minutes.
Well, we got it on time here, and it'll time, and then we'll put that charge that we take in, we'll put the charge back in the batteries. Okay, so these batteries are sitting at 14 volts. So they're fully charged, supposedly. They're sitting at 14.54 volts. 3 minutes to go. Okay, so we're taking the energy, this 100-watt light bulb. So we're past the normal draw of the 100 amp hour battery. We're around 9 amps draw from this battery right now. In other words, the C20 rate, discharge rate for this battery is about 2 amps max. And so we're more up like on the C5 scale. So we're asking it to do a lot. Okay, we're ready to go. So now what we're going to do is we're going to take another capacity test to see where the battery's at. Okay, we're at 81% capacity. So we've actually taken, 10% of that out. Okay, now, what we're going to do is we're going to show you what the signal looks like first. Let's see here. There, now the pendulum, this is what the signal is going to look like. That's the only signal there's going to be. Okay? Now we're going to put this on here. Oh, let's see here. Clamp the battery on there. We're going to start the machine. Okay, and the way this machine works is the motor force, you can watch this real quick here. The motor force drives it back and forth each time, but gravity brings it back down. So it comes across the pole piece really quick. And what we want it to do is get gravity to get it up here so it comes across the pole piece quick. And we're going to do this for 5 minutes. So what's happening is there's only one motor push on each swing. And when the impedance is equal, this will be up at 90 degrees. And see, we're using a very high impedance in the front and a very low impedance in the back, so it's sort of like what Tesla was doing. And we can look at the voltage. So you can see there that it's swinging this battery back and forth. That's driving the pendulum. All it's driving there is the trigger, because it's not capable, if it wanted to balance with the batteries, it wouldn't be at a 14 volts. All right? So what we want to do is we want to give this 5 minutes with this signal wave that's aided by the gravity wave, which works with the pendulum. And then we'll check this battery. We should be back up to 90% capacity. We can take another 100 watts out of it. So it's an impedance-driven machine. Same as the SG circuitry. Only done in a pendulum. Kind of like a big TikTok. That's okay, you should have seen these things swung up to 90 degrees. It's scary when the magnet's this big. This is scalable. This is scalable. You have one scale here, you have another scale there, and then if you get your camera back over here, you have one more scale yet, which is right here. Believe me, that has swung up to 90 degrees right out there. Turns out the smaller machine works the best. Well, actually, I wanted to take it down to something, really small in size. And it works the best with one winding and not the multiple windings. Tesla made a couple of oscillators just like this. And one of them was the earthquake machine. All right? Where it just does this constantly. Bang, 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 bang. See, and this pulse is a sharp pulse. It's just, see how fast it goes across the pole piece? Okay. And it doesn't make any difference if it's going this fast. It's still doing the same thing. All right? Or if it's going that fast. But it maintains a speed constantly. You know, unless there's no front end on it. And it actually is flip-flopping the batteries backwards and forwards. But they never equal each other because it's always a zero in the center. You see what's happening here? This battery, it finds its center, and then it stays without adding anything to this battery. And in fact, the higher the impedance here, the better this stays charged. So we're using a really small battery here to charge a 100 amp hour diesel battery. Which you can't do with one of these Excite chargers.
This isn't radiant energy, per se.
Yes, it is.
This is radiant energy.
Yeah, it's timed. It's a time wave. It's doing, okay, so there. We can't have no more. So let's see where it got the battery in that amount of time. Right on the button, man. Every time. So you didn't use anything here, look. What did you actually use out of this battery? You didn't use anything because gravity's aided, adds to this. The only thing we want is the trigger pulse, and we want all the motor force to go away. All right? So if we put a bigger battery on the front here, we can actually, if we give this a little bit more time, here's the unique thing about the pendulum, is there's no boiling of the battery. There's no current that's being taken in massive amounts to charge that battery. It's all about moving one charge in the signal. It's the signal that's important. That signal that we've seen on this. Would you like to see the signal again? So what we have here is a balancing force. And you can see the motor force. And you can see the trigger pulse that it's letting loose. Let's just say we won't be able to test this very well because this is not really a good battery. But let's just suppose we take this dead battery. So you can see the signal that's going to go to the battery. Okay, so there it is. So what we're going to ask this machine to do is balance the battery without taking anything from this battery over here. Okay, and you can see it's balanced the two batteries now. Now we're going to ask for the signal to recharge. And see, it's coming downward. Because we're just asking for that signal to recharge it. And so for the battery to recharge, it has to move the lead between the plates. And so that means it's got to come down because its impedance has to go up. And see, now look at the pendulum swing. You can see that it's going much higher than it was with the 100 amp hour battery. So it knows that that impedance is high and that impedance is high. So this is going to come up further. So the crappier this battery is, the higher the pendulum's going to come up and swing on a motor force. And the faster the pulse is going to be to that battery. And there's no feedback
Well, how does it know?
because of the impedance.
Okay.
The impedance of that battery versus this battery versus the circuit.
Yeah.
So this wants to sit at 0 all the time. So it has to make the two batteries balance.
Yeah.
Okay, so is it really in that battery? Is it really putting it over here? It says it is. See, now watch the pendulum when I couple the wrong impedance to it, which is the light. See, it's going downward. In other words, it knows there's a low impedance here on it. We'll just use the impedance of this battery. It's what Tom Bearden talks about. It's just a sharp transient across the coil that lets this radiant spike loose. See, here it's switching on down here, and then bang, it lets it loose. And then the circuit in there catches it, catches the spike. But before, this is a little bit different mechanism than the SG because it balances the batteries. It causes the batteries to rock back and forth.
So essentially you've closed looped it.
Yes, it's closed looped. And essentially this is the primary signal. And let's look at the secondary signal. Get the gain. Look at the signal. Totally different, see? See, there's the switching wave from the pendulum right there, and there's the gain. See, here's the impossibility. The impossibility is that there's no possible way that you can take this battery and put it across that battery and go from 81% to 90%. The mind of the skeptic. What drives the skeptic, right? What drives the skeptic is somebody that doesn't believe in his own work. He doesn't believe that anything's possible because early on in age, he was totally brainwashed. In other words, 1 and 1 equals 2. Well, what if 1 and 1 doesn't equal 2? You see my point? What if 1 and 1 actually equals 1100? You follow me? Hey, a skeptic looks at a machine, and since society has programmed everybody from day one, childbirth, that this is impossible, guess what? It's impossible. The skeptics are plants on the internet. It's the same thing as the 1 watt challenge. Can you make the energy machine run itself? Well, anything that has to do with nature is an open loop system. You don't see a big, conglomeration, closed path around the earth, shorting out its magnetic field, right? Because everything that has to do with the radiant energy or energy from the vacuum is in an open loop system. So here's how you do it. You initially build something which is, by all conventional means, right down to earth. It's got its own closed loops. The circuit by itself has its own closed loops. All as you're telling this circuit to do is please instead of shorting out this energy, let's capture it. So if we want to run a motor, we want to run the motor, we want to collect the output that's wasted, send it to another battery so that we can recycle the energy. See, it's nothing more than recycling tin cans. In other words, let's reuse everything that the circuit threw out. You see? And by reusing everything that the circuit threw out, the vacuum adds its own energy, and that's the term. This is where we get the energy from the vacuum. You follow me? The vacuum absolutely inputs the energy in a radiant form. And it's that radiant form that we want to catch. So the skeptic, right, says the circuit's not running right. It's got this big spike, it's ringing, it's doing this, it's doing that. We need to get rid of all that. Look, it needs to be nice and square. And so we have designed all our circuits to be free from what? Radiant energy. So they want to see a straight line. Of course, under the conventional, normal circuits, you can't have more out than you put in, right? So herein lies the mind of the skeptic. The skeptic says, this is all wasted stuff. We don't need any of this. See, we're only interested in this measurement because the skeptic only has the tools that were given to him by a skeptical society in the beginning.
What is next?
The Bedini motor.
The Bedini motor. You know, the Bedini motor is like the holy grail of the free energy freaks.
It couldn't be simpler. A battery drives a motor which spins up a flywheel, which charges wire coils, which in turn recharge the battery. And bingo, a perpetual motion or over-unity machine.
It's important to keep an open mind and realize that all the principles that drive the over-unity machines operate outside of everything you've ever heard about science.
What did they do wrong? Well, for starters, there were no magnets on the flywheel. They just ran this out of the blue, but it was only after there were 400 or 500 people on this SG group, you know, that we're starting to build these monopole motors and starting to get results with the motor working, and they seen that I was charging the battery and doing the mechanical work. Just in about the middle of this, all of a sudden out comes this myth. It has nothing to do with a schoolgirl motor. It's something that was done in 1984. It's something that Watson proved without a shadow of a doubt that it operated, because he isn't here anymore. You know, where that went, nobody knows. But it had nothing to do with the schoolgirl motor. But yet here they come, right at the peak of this schoolgirl motor. You know, here, we're going to get this guy. You know, we're going to come out with this program and disprove that this thing, it just doesn't work. Well, yeah, you could see that it didn't work. The coils weren't wound right. The motor wasn't right. You know, there were no magnets on it. The mass wasn't even, there was nothing on this thing that remotely resembled what Watson did or what I did. It was just a mismatch. It was a Rube Goldberg machine is what it was. Never did they contact anybody. And they did it on national TV just to discredit the whole thing. That's my opinion of it. You know, and there never was any kind of comment. And you couldn't send them an email, you couldn't do anything. Why don't you do this correct? There was none of that. It was just, we're going to just disprove this and see it doesn't work, folks. Here it is. Of course it didn't work. Didn't even have any magnets on it. And the most unique thing about the Mythbusters is they had some MIT professor standing there that knew better. You know, that knew that this thing wasn't going to generate anything because he left out the magnets. You know, there was nothing to go by the coils, nothing, no energy to be generated, just a waste of energy.
MIT's Dr. Geo Holmesy has been helping the guys by assembling the contraption. And with his pedigree, they're quickly in business.
Free energy, man.
Here we go. Activate the modulator.
Modulator activated.
A modulator switches the motor on and off, so preserving power while the flywheel keeps on spinning, in theory, replenishing the battery.
Okay, it's spinning up. I can hear it getting slower.
Yeah, it seems to be.
I don't think I need a meter for this one.
In a sudden burst of free energy, the Bedini machine runs down.
Sounds like my grandfather.
Oh, getting sick. It's draining more from the battery on each cycle than it's putting back in when it recharges.
That's the one big problem with perpetual motion machines. They're not perpetual.
Over unity, huh?
That's an efficiency of over 100%.
Kind of makes you feel all warm and fuzzy inside, don't it?
If you mean it makes me feel like I feel about the Easter Bunny or Santa Claus, yeah, that kind of warm and fuzzy, because it's a fantasy!
So what do we do with a skeptic? You present a challenge to the skeptic. You get on there and you invite the skeptic. And you say, look, you come and do this for yourself. They won't. They refuse, and even if they did come and do it, they would still deny it. In the end, they would say, nope, I didn't see that. That really didn't happen. That doesn't work that way. See, it's all programming. You see, and it's also difficulty for the skeptic or the skeptical engineer to design a circuit using radiant energy. They haven't been trained in doing it. And they don't get it. They don't understand it. They refuse to look at it. They're blind. So, if the little kids are taught right from the beginning that this is the way you make this machine, and this is why it works this way, and see, you don't need to do this, and you don't need to do that, and you don't have to have any of these things. And see, you still have mechanical energy, and look, you're doing this for milliamps instead of amps. Batteries, right, are going to want to run on nature's timescale. Follow me? Nature's timescale says that the battery has a certain rate of discharge for so many hours. You want to stay within that range. You see, otherwise you're harming the battery. The chemical process is causing heat. Cause heat, that's energy that you can measure that's wasted. You follow me? So, when you present a skeptic this, and you say, look, I'm willing to take your challenge.
I summarize this as the 1 watt challenge, which is, I think, that what it's going to take to move forward for any of us is to have the demonstration device in a standalone self-powered basis continuously generates at least 1 watt excess average output power.
I'll take your 1 watt challenge, but these are the rules. I can run an open loop system. I'm not going to couple it back. In the end, what I'm going to do is I'm going to hand you this item and say, tell me how many amp hours you got out of it now from what you put in. Very simple procedure. It's the same thing as a 1 watt challenge. So we're looking at it this way. If I let the skeptic build a circuit, which he says charges the battery, and of course under conventional means, because they're not going to vary, from the textbook operation of this. They're going to boil the battery, they're going to apply huge amounts of current to the battery. I'm not going to do that. The point is, the skeptics are here to keep you burning the energy so that you have to pay for that energy. The thing is that radiant energy is so simple, it surrounds everything that we do. The plants use it all day long, the trees use it all day long, the earth uses it all day long. I mean, the earth communicates with the earth. There's currents running through the earth. You see, it's just a matter of tapping it to get what you want, and then not killing the dipole. In other words, we don't want to kill the dipole. We don't want the plus and minus to go away. We want this energy to keep flowing. We just want to tap a little bit out of it. We want to use that little bit that we tapped to charge something so that we can run our conventional stuff, which the skeptics have designed, because that's what we have.
I think that eventually we'll be able to power the world with negative energy very cheaply and very cleanly. But it is different to use. Your mind has to think backwards on a lot of things that we were all taught in electronics or in our electrical circuits and in power systems and so forth. Now, the amazing thing about negative energy is today, all of our loads, our motors and things like that, are all designed for positive energy and they're designed for system losses. One day in the future, when we are using and able to use negative energy, we will use loads that are specifically designed for negative energy, and they will just be another amplifier gain. Maybe the load itself will increase the gain 100 times what you're putting into it and you're paying for on the front end. And if you need not to pay that much, you put a few impedance sections before you get to it. What we're saying is, I'm not saying it can be done right now. I'm saying that just if we considered we could develop this very adequately as we went over a period of time, in the future, we'll be able to take a flashlight battery and power New York City, at least in theory. In the real world, maybe we could take that flashlight battery and power one home. Let's look at something a little more realistic. Well, that would be a marvelous thing, because think of how much coal and oil and all that you would save. So as far as the biosphere is concerned, you could really clean up the biosphere. As far as the economics, all modern economics is based on cheap energy, and we would hope cheap, clean energy. It'll deliver you the cheap, clean energy to have a much higher economy for everybody.
It's our point in the future to not consume. We don't want to consume anything. We want to be able to use the energy but not consume it. And it's not as if we're poking a straw in something and letting the air out of a balloon. So we're not going to shrink the earth, if that's what everybody's thinking. We're not going to tap something or cause harm, that could backfire on us someday. You see, but the other alternative is, let's just continue to do what we're doing. And I guess we all shall find out pretty quickly that we've consumed it all up, when we could have used it. But I have faith. I have faith that maybe the new electrical engineers might have to look at something different, because radiant isn't the same thing. You can charge batteries with it, you can heal with it, you can transmit with it, you can have communications with it. If we could get through the political end, all the politics being played, and all the little whitewash games, and this game and that game, and the status quo. Yeah, the stuff that if we can get through this, then I think we maybe might have a really bright future.